Toyota production system was established between 1948 and 1975 by Japanese industrialist Eiji Toyota and Japanese engineer Taiichi Ono. The Toyota production system is the original form of lean manufacturing, and it is based off of two concepts, jidoka and just-in-time. Jidoka is a way of spotting problems and taking prompt action to correct faults at any stage in the production process. Machinery will automatically detect an issue and safely stop so that an inspection and any necessary adjustments can be made. Information is shared with others on the and-on display board, and operators can continue working on other machines. The concept of just-in-time means make only what is needed when it is needed at every stage of production. This concept requires the production line to be stocked with all the right parts in the right sequence at the moment production begins. As parts are used up, new stock is delivered at the right time, in the right quantity, so there's no interruption or slowdown in the production process. What is the Toyota Way? The Toyota Way was formally established in 2001. It is a management approach that goes hand in hand with the Toyota production system, and it was adopted by auto manufacturers worldwide. First and foremost, the Toyota Way is a set of principles that focus on eliminating the 7 wastes, or muda in Japanese. These 7 wastes are overproduction, waiting, transporting, inappropriate processing, unnecessary inventory, unnecessary or excess motion, and defects. The goals of the Toyota Way are to optimize each step of the manufacturing process, to produce products with no defects, to reduce costs, to make a product that is in demand, to have flexibility, and to focus on the customer-supplier relationship. The 5 principles of lean manufacturing are derived from the Toyota production system. These 5 principles are value, value stream, flow, pull, and perfection. The first principle in lean manufacturing is value. Value is determined by specifying what customers need and want and how those can be met. The goal of this principle is to design products that meet the needs and wants of customers and to remove features that do not contribute towards meeting those needs or wants. Value is synonymous with what a customer is willing to pay for a product.
Understanding the value stream and how each part affects the product being manufactured is very important to reducing the 7 wastes and approaching a fully optimized manufacturing process. But first, how can a company, and in our case, Toyota, understand and eventually use this idea to improve their business? Well, the value stream is often mapped using a diagram like the one you see to the right. These diagrams detail each and every manufacturing process up until the product is in the hands of the customer. This helps make it clear which processes are wasteful by categorizing them into 3 types: non-value adding, necessary but non-value adding, and value adding. All non-value adding processes should be removed from the manufacturing process. Value adding processes should be kept, and necessary but non-value adding processes should be looked at for further optimization. Flow is a concept that is very closely related to the value stream, as it tracks how the products move between each process of the value stream. Any breakdowns in the flow of a manufacturing system can create opportunities for waste to accumulate and are not acceptable when trying to fully implement the concept of lean manufacturing. There can be both physical and intangible barriers to flow, but both are equally important to mitigate. Physical barriers include long distances products have to travel between manufacturing steps, long equipment setup times, batch-oriented machines that function better when a certain number of products are being made, as well as poor maintenance on said machines. Intangible barriers include unreliable delivery of raw materials, unreliable quality of raw materials, lengthy approval processes, lack of faith from employees that a lean manufacturing system can actually work, and a resistance from these employees to change from another system to a lean manufacturing system.
With the pull aspect, it prompts new items to be manufactured and signals for additional supplies to be purchased. An example of this includes the Kanban system. The Kanban system utilizes a 3-bin system for the overall demand of product parts. The first bin is used to satisfy the initial part demand. The second bin assesses the part from inventory. The third bin supplies the part for distribution. Kanban cards like the ones shown are used in bins to provide product detail and other information about the part. Benefits of the pull aspect include increased output, maximized usable workspace, reduced inventories, and the elimination of overproduction and underproduction. The perfection aspect requires companies to continuously improve their practices. It often requires a shift in the workplace culture. The philosophy of continuous improvement is generally known as Kaizen. Kaizen focuses on incremental changes. It requires every worker, from every corner office to the factory floor, to help improve the business practice. Benefits of the perfection aspect include increased efficiency, greater productivity, better quality products, and lower costs.